Hello children, today we are going to discuss chapter Chemical Reactions and Equations. What is a chemical process? A chemical process is that in which one or more substances are formed. The substances which are formed should be new. They should have different composition than the reactant. This chemical process generally can't be reversed. Like hydrogen plus oxygen gives you water. This formation of water is a chemical process. Chemical processes involve different types of reactions in them, in which different types of observations can be seen. Like we can see the change in color, we can see the change in state, we can see the change in temperature, or there could be evolution of gas. That all we will see in different types of reactions one by one. We have certain examples of chemical reactions in our daily life. Like we are having digestion of food. When we take food in, it combines with oxygen. Glucose present in food is broken down to form carbon dioxide plus water, along with energy. That energy we are using in our day-to-day activities. Process of respiration, in which we are inhaling oxygen. That oxygen combines with your food and turns to carbon dioxide gas. Then rusting of iron, then formation of curd from milk. These all are examples of chemical processes. Further fermentation of grapes to form wine. These are examples of chemical reactions. Then you can have different examples of chemical reactions like burning of paper. When we burn paper, it leaves behind ashes only. Ash is having different composition than the paper. Then photosynthesis process, baking of a cake. These all are examples of chemical reactions which are happening around us every day. Then acid base reactions. Acid plus base combines to form salt plus water. This is example of neutralization reaction. Then organic waste decomposition. Formation of compost from vegetable matter is also example of chemical reaction around us. In a chemical reaction, we have two components, reactant and product. Reactants combines to form product. When we write a reaction, we write it in this way. We are writing hydrogen combines with oxygen. It forms water. Here we are using symbols of reactants and products. This equation we are writing as chemical equation. If we write in the form of words only, like hydrogen plus oxygen to form water in English letters, then it is called word equation. This equation, which is not having equal number of atoms on both sides, is called unbalanced equation. This equation needs to be balanced so that it can follow law of conservation of mass. So we will write here 2. We will write here 2. Then it will become a balanced equation. Unbalanced equation is also called skeletal chemical equation. Like you are having burning of magnesium ribbon. Magnesium ribbon burns in presence of oxygen to form water, to form magnesium oxide, sorry. This is again unbalanced equation. We need to balance it. So for balancing, we will write here 2. Now this is balanced chemical equation in which number of atoms are equal on both sides. So this was method how we can balance a chemical equation. For balancing a chemical equation, what we need to do? We need to follow certain steps to balance a chemical equation. Say you are having iron plus water gives you Fe3O4 plus hydrogen. First of all, we will write here elements. We are having iron. We are having hydrogen, we are having oxygen. We will write number of atoms. Iron on left hand side it is 1, hydrogen is 2, oxygen is 1. On right hand side, iron number of atoms are 3, oxygen is 4, hydrogen is 2. So hydrogen is having equal number of atoms on both sides. So we will write with maximum number of atoms and then we will follow minimum number of atoms. So you are having here oxygen as 4. So we will write here 4 in front of water. After that for iron you can go with 3 atoms of iron. Then this equation is now balanced. What we need to follow to balance a chemical equation? We need to follow law of conservation of mass. Means mass can neither be created nor be destroyed in a chemical reaction. So on left hand side and right hand side, number of atoms of reactants and products should be same. In types of chemical reactions, first reaction is combination reaction. In this reaction, 2 or more reactants combines to form single product. Like you are burning coal in presence of oxygen. It forms carbon dioxide along with heat and light. This is example of combination reaction where carbon combines with oxygen to form carbon dioxide. When you are burning hydrogen gas in presence of oxygen, it forms water. This is again example of combination reaction. We can balance it by writing 2 here. 2H2 gives you 2H2O. 2 hydrogen plus oxygen forms 2H2O. This is also example of combination reaction. Then we have decomposition reaction. Decomposition is just inverse of combination reaction. Here, one reactant is splitting into 2 or more products. Like you are having calcium carbonate, limestone, when heated, it forms calcium oxide plus carbon dioxide. Decomposition reactions are of 3 types: thermal decomposition, electrolytic decomposition, and photolytic decomposition. Thermal means heat. When you are heating a substance and it is breaking down into its constituents, into its components, it is thermal decomposition. Electrolytic decomposition means you have to give electric spark and it will break up into its components. In photolytic decomposition, we are keeping things in sunlight or in different forms of light and it is breaking down into its constituents. Here you are having example of electrolytic decomposition. We are taking water. Water, when electric spark is passed through it, is breaking down to hydrogen and oxygen, 2H2 plus O2 will form. In this process, we are taking water in a container, then we are having 2 electrodes. We are adding 2 to 3 drops of acid in it, and you will see that on anode, oxygen gas, on cathode, hydrogen gas will start coming up. Then we have photolytic decomposition. We are taking silver chloride in a watch glass and keeping it in sunlight for some time. It will break up to form silver plus chlorine. This is example which is used in black and white photography. Next is displacement reaction. Displacement means in which more reactive element displaces less reactive element from its salt solution. We are keeping an iron nail and keeping it in copper sulfate solution for some time. Copper sulfate solution is blue in color. When iron nail is dipped in it, iron displaces copper from its salt solution. It turns its color, it will start fading up. Ultimately, it will start turning to light green in color. This is example of displacement reaction. For knowing the displacement reaction, you should know the reactivity series. First of all, learn reactivity series, then only you will be able to write displacement reaction. Now I'll tell you how to write reactivity series. It is Kadar, Nath, Ka, Munshi, Alu, Zara, फीके से पकाता है क्योंकि हर आदमी आलू पकाता. The elements which are present on the top are most reactive. The elements which are present in the middle are moderately reactive. And the elements which are present at the bottom, they are least reactive. So, more reactive element can displace less reactive element from its salt solution. Next is double displacement reaction. In double displacement reaction, there is mutual exchange of cations and anions. You are having here sodium sulfate reacts with barium chloride to form barium sulfate plus sodium chloride. It is ionic reaction. Here you are having 2Na positive, sulfate 2 negative, it is barium 2 positive, two chloride negative. Cation of this combines with anion of this. Cation of this combines with anion of this. So it forms 2 NaCl. It forms Ba2 positive, SO4 2 negative. So it is BaSO4. This is double displacement reaction where white precipitates of barium sulfate will form. It is also termed as precipitation reaction. Next is redox reaction. Redox word is combination of two words, reduction and oxidation. Oxidation means addition of oxygen or removal of hydrogen and loss of electrons. Reduction means removal of oxygen, addition of hydrogen or addition of electrons. You are taking here copper metal, burning it in presence of oxygen to form black color compound copper oxide. We can balance this equation. This is oxidation of copper which is taking place, right? Then copper oxide is treated with hydrogen to form copper plus H2O. This is removal of oxygen from copper. So what will happen in case of this? Hydrogen is getting oxygen, hydrogen is getting oxidized and copper is getting reduced in this reaction. We can mention here in this way also in terms of electrons. Here oxygen is having -2, copper is +2 oxidation state. Hydrogen is in 0 oxidation state. Element in its elemental form is always having oxidation state 0. Hydrogen is +1. Oxygen is -2. See this, copper from +2 oxidation state is changing to 0 oxidation state. Hydrogen from 0 oxidation state to +1 oxidation state. Copper is gaining electron and hydrogen is losing electron. Next is corrosion. Corrosion is eaten up of the metals by air, water, acid, and different kind of impurities present in the atmosphere. This is type of reaction in which metal is getting weakened up. This is in case of iron is called rusting of iron. Then silver is getting a black coating over itself. Copper is getting a green coating. What is actually happening? We can see with the help of reaction. Iron when combines with air, it is getting oxygen and water. Certain water molecules are combining it with, say, X water molecules are combining with it. It is forming iron oxide, Fe2O3 dot XH2O. This is formation of rust. Silver metal when combines with H2S present in air forms coating of silver sulfide over itself. That is formation of black coating on the surface of silver. It is forming Ag2S. Plus hydrogen. You can balance this equation. Then you are having green coating over copper. Copper metal when exposed to carbon dioxide, oxygen and water, it gets the alkaline coating over its surface. That is formation of alkaline copper carbonate, CuCO3 dot CuOH twice. I'll write this again. Formation of alkaline copper carbonate is CuCO3 dot CuOH twice. Alkaline copper carbonate is formed, which is green in color. Aluminium metal, when exposed to air, it gets the coating of aluminium oxide, which is a self-preventive coating. It doesn't allow aluminium to react further with air. How we can prevent corrosion? For preventing corrosion, we need to cut out the supply of air with the metal. We can cut the supply of air by painting, greasing, galvanization, chromium plating, or formation of alloy. Formation of alloy means we are reacting metals with other metals or non-metals. Say you are having a sheet of iron. Iron atoms are bigger in size and we are adding carbon in it. It is like you are having a stack of footballs and you are just filling the gaps or the voids with the tennis balls. So in between these iron atoms, when you are filling here, carbon is occupying these voids. So there will be no space left for air and water to get inside. So corrosion can be prevented. That's all about this chapter. Thanks for this patience listening. Thank you.